In this lesson, we're talking about logarithms, and it's a complicated word to spell, and a lot of students are intimidated by logarithms, but they're actually not as complicated as they might sound. So, let b and x be positive numbers and b is not equal to 1. That's just part of the definition of a logarithm. Logarithm of x with base b, it's denoted like this. This is the mathematical way to write a logarithm. So you have log, L-O-G, of some base, which it'll be a number, like 4, and then you'll have some other number next to it. So like log base 4 of 16 is how you would write and say that. What is a logarithm? A logarithm is an exponent. And that's really important to know. Logarithm is an exponent. So if someone asks you, what's a logarithm? Or if I ask you, what's a logarithm? You should say, oh, it's an exponent. That's all it is an exponent. Specifically, it's the exponent that makes this equation true. So b to the y equals x. Whatever y equals, we can use a logarithm to figure out what y is. So if we have b to the y equals x, we can rewrite it as a logarithm to be log base b, there's the base right here, that was this base right here, of x equals y. So this is a really important concept. Ooh, green. Really important concept that you're able to write from one form to the other form, which we're going to start doing soon. But why need logarithms? Why use them? There are some equations that are really easy to solve without logarithms, like 2 to the x equals 8. Hopefully it doesn't take too long to figure out that x is 3. There are other equations, like 2 to the x equals 11, which you could make a guess. Well, it's a little bigger than 3, maybe 3.2, 3.3, 3.4. I don't really know. How do we know the exact answer? We can use what's called a logarithm to find the exact answer of an equation like that. So, two things. Logarithms equal exponents. So if I ask you what is a logarithm, what does this logarithm equal? It equals y, which is an exponent. Logarithms are exponents. The word logarithm comes from two words. Maybe it'll help you to spell it correctly if you can spell the other two words. Logarithm comes from two words, logical. So the log, and logarithm comes from logical. And the other word, arithmetic, logarithm, the other word is arithmetic. Arithmetic means calculations. So it's a way to do calculations, logical way. So it's a logical arithmetic. Logarithm, and that's how you spell it. Log, L-O-G, and then arithmetic from arithmetic. A guy named John Napier invented logarithms about 400 years ago, 500 years ago. He invented them to allow us to change complicated exponential equations into simple arithmetic. And we'll see that a little bit more in tomorrow and future lessons. And logarithms are used in a variety of contexts. Decibel level is referring to sound, how loud something is. So you can measure how loud something is with logarithms. The Richter scale, so decibel level is sound. The Richter scale is for earthquakes, which we get in California occasionally. Earthquakes, how bad an earthquake is, can be measured with logarithms. pH scale is a science application, how acidic or basic a substance is. So pH scale. You can use logarithms to measure that. And then light intensity, how bright something is to our eyes. You can use logarithms to figure out how bright something is. Okay, so on the next part, I just want you to get used to using this idea right here. So the next part of the notes, we're just using all of this. So write each equation in logarithmic form. So the first one, the big 3 right here is the base, and the little 3 is the exponent. So we could write this as log base 3 of 27 equals the exponent. Logarithms equal exponents. So this log equals the exponent of 3. And it doesn't really solve anything. It's just rewriting, so you can get used to rewriting it. I'll show you the next one, and then you can do the last one. The next one would be log base 1/3 of 9 equals the exponent. The exponent is -2. Log base 1/3 of 9 equals -2. So pause this video and see if you can answer the next one. The next one we would say log base 2401 of 7 equals 1/4. So you'd say log, and this is your base, log base 2401 of 7 equals 1/4. The next ones, we're going to go the opposite direction. So to write these in exponential form, we would write the base first, so base 13. The exponent is 2, and it equals 169. So 13 squared equals 169. I saw a teacher before do this, going from this form. If you start with the base and you go this way, then it's 13 raised to the 2 equals 269, just to get used to the order that you're supposed to write the numbers. The next one would be 1/5 is your base, raised to the -2 equals 25. And pause this video and see if you could write the next one. So the next one we have a to the g equals m. The next part, we're going to basically use the same idea right here, and we're going to now evaluate different expressions with the definition of a logarithm. Definition of a logarithm just means to rewrite it in exponential form, b to the y equals x. So for instance, on the first one, log base 12 of 144, we're going to say it equals something. You could use any variable, like n. And then you rewrite it, 12 to the n equals 144. And if you stopped and thought about it, 12 what? 12 to the what equals 144? Well, that would be 12 squared. So the answer is 2. So log base 12 of 144 equals 2. The next one, we could say log base 3 of 1 over 81 equals something. So we could write 3 to the n equals 1 over 81. And 3 to the what is a fraction. If you have a fraction, you're going to need a negative. So negative sign. And then the 81 compared to 3, 3 to the first is 3, 3 squared is 9, 3 to the third is 27, 3 to the fourth is 81. So it would be -4 is the answer. And why don't you pause this video and try the next 2 or 3. So this answer we have n equals -3, and there's the work shown. On the next one, what would you write? So this one we'd have 25 to what equals 1. And to get a 1, it must be 25 to the 0 equals 1. So n equals 0. The next one might be a little confusing to use an n since we have a bunch of n's. So maybe I'll just use a question mark. You could use an x or an r for Richard or something like that. So we have n to the what equals n, and that would be a 1. So the question mark equals 1. Or if you use an x, you would say x equals 1. For the last one, if you rewrite it, the base is 5. You want to know what the exponent is. 5 to the what equals -5. And if you think about it, you know, maybe you're conjecturing some numbers. If you tried 5 to the 0, does that equal -5? That's not true, because that would be 1 equals -5. If you tried 5 to the -1, maybe, does that equal -5? And that's not true, because that would be 1/5 equals -5. So that's not true. So 0 doesn't work, -1 doesn't work. What other numbers could you use? Maybe, I don't know. How about to the 1/2? Does that equal -5? No, because that's the square root of 5 equals -5, and that's not true. So after you've tried a bunch of numbers, you realize nothing actually works. So we would say that the answer is undefined. There's no number that works to answer this equation. So anytime you have log of a negative number, you get undefined. On the next page, we're going to solve some equations. And solving equations, we're going to use the definition of a logarithm. Definition of a logarithm is if you have log base b of a equals n, you could rewrite that as b to the n equals a. So that's the idea we're going to use on many of these. You have to be aware of extraneous solutions. Extraneous solutions are solutions that you get, but they don't actually work when you plug it in. Negative numbers. So if you have log of a negative, that would be extraneous or undefined. So to solve equations like this, you're going to rewrite this in exponential form. You'd have 25 to the 3 halves equals n. And you could either use your calculator, 25 raised to the 3 over 2, get the answer. Or you could write the square root of 25 to the 3rd equals n. So that would be 5 cubed equals n, which is 125. The next one we could rewrite as 10 to the 1st equals x squared plus 1. And to solve for x, we don't really need to factor. We could just subtract 1 from both sides. And then take a square root, and we get plus or minus 3. 3 squared is 9, and negative 3 squared is 9. And notice when you plug in 3 or negative 3 into the original, you're going to square it, and both will be positive. So you have log of a positive number. So both answers are acceptable. Negative 3 is not extraneous. Not extraneous, because when you plug it in, you'd get log base 10 of 10. Negative 3 squared plus 1 is 10, and 10 is positive. Okay, so how about pause this video and see if you could do the next 3 questions. So on this one, you'd write 4 to the 5 halves equals n, which should be the square root of 4 to the 5th, which is 2 to the 5th, and that's 32 is the answer you should get for that. The next one you have 8 to the 4/3 equals n. That would be the cubed root of 8 to the 4th equals n, which is 2 to the 4th equals n. So n is 16, and neither of those are extraneous. On this one, you'd have b squared equals 121, and what squared is 121? That would be 11. And it's plus or minus 11, but the base cannot equal negative 11, so you only have a positive 11 for that. So square root plus or minus, but a base has to be positive based on how a logarithm is defined. For the next one, it's actually pretty easy, easier than the ones we were just doing actually. If you have a log on both sides with the same base, you can cancel them and set the rest equal to each other, and then you'd subtract and take a square root, and you get plus or minus 8, which if you plug in negative 8 here, it becomes positive, so it's not extraneous. Both answers are good answers. And you could do the same for the other ones. So you have log 5, you can cancel them. You have p squared minus 2 equals p. And to solve that, since you have multiple variables, you want to put the variables on one side. You have p squared minus p minus 2 equals 0. And you factor p minus 2, p plus 1 equals 0. You get 2 answers, 2 and negative 1. But notice about the negative 1. If you plug negative 1 in for p right here, you would have log of a negative number, which is undefined. So 1 is extraneous, and p equals 2 is the only solution. And the last one, you can cancel out both logs. You have 4y minus 10 is greater than or equal to y minus 1. Subtract y, add 10 to both sides, and you get y is greater than or equal to 3. There's one type of example I should have put in the notes, but I neglected to. What happens when you have a log in the wrong spot? and I did the last function. I will not require that you graph logarithmic functions, but this is what it looks like. But the main part of the notes are above. Thank you for your attention.